Let's have a bit of a look at cubics then. Spend a lot of time in junior school with quadratics. We do quadratics to death, really. Should be on top of it. You know, factorising, expanding out, all those sorts of things. Cubics probably don't spend as much time, but we should know these expansions just as well as we know the perfect square. The perfect cubed, a cubed, 3a squared b, 3ab squared plus b cubed. Again, there's a pattern to it, and that's how I remember it. Powers of a start at 3, go down by 1. Powers of b start at 0 and go up by 1. The two powers always add up to be 3. So a cubed, a squared b, ab squared, b cubed, and the coefficients go 1, 3, 3, 1. The minus 1 is similar, but the signs alternate. You start with plus and then go minus, plus, minus, plus. Factorising, difference of two cubes. A minus b, a squared plus ab plus b squared. There is a huge mistake people often make with this. What do you reckon it is? Yeah, because we're so used to with that quadratic going 2ab. But it's only ab. It's only ab. Now, they're very similar. How I remember it, they start off the same way as the question. So a minus b cubed starts off with a minus b. A cubed plus b cubed starts off with a plus b. Then in the second one, it's the middle term that has the opposite sign. Minus was in the first one, plus in the second one. Plus in the first one, minus in the second one. And again, you'll notice that pattern with the powers. They always add up to 2 in that expansion there. So 2a minus 5 all cubed. Once again, may not be something you necessarily write down, but you might be doing that in your head. But there's the pattern. Cube minus 3, first one squared times the second one, 3, first one times the second one squared, minus the last one cubed. There we go, tidies up. X cubed plus 8, 8 of course is 2 cubed. Again, you wouldn't necessarily write that line down. So we start with x plus 2, x squared, but it'll be minus in this case. The product, 2x plus 4. Again, 27 is 3 cubed. So we have the difference of 2 cubes there. So it starts with y minus 3a, y squared plus the sign will change. So product, 3ay, and then the last one squared. That pattern generalises. Okay? Not actually in the syllabus, but it is handy to know. You could go any power you like. You always start with a minus b. So if you've got a to the power of n minus b to the power of n, you start with a minus b. Powers of a will then go down by 1. Powers of b will go up by 1. The two powers will always add to be n minus 1. The plus case only works for odd powers. So that's why we had a formula there for the sum of 2 cubes. We don't have a formula for the sum of 2 squares. So it only works for odd. And the difference with it is, it would start with a plus b, and these signs will alternate. They'll go minus, plus, minus, plus, minus, plus, all the way down. So if I want to do x to the 5 minus y to the 5, there is x minus y. Powers of x go down by 1. Powers of y go up by 1. There it is. Let's see how we handle the plus. It's an odd power, so it will work. Because really, what we're doing is we're saying minus 1 to the power of 7. And so that's why it works with minus, or like with odd powers. But if it's an even power, I can't write it as minus 1 to the power of something, because it's not going to work. Okay. So in that case, that explains the alternating of the signs, because if it's an odd power, it's a negative. If it's an even power, it's a positive when we do that expansion. Theoretically, they will factorise. Because all polynomials can be factorised down to a combination of quadratics and linear functions. Is why all that work on linear functions and quadratic functions is so important. Because everything can be factorised down to a combination of linear and quadratic functions. All right, there we go. 1E, a few asterisks there. That means good extension questions.